Glass, a seemingly invisible material, has been quietly shaping our lives for centuries. From the delicate curves of ancient Roman glassware to the modern marvels of smartphones and fiber optics, glass has played a pivotal role in revolutionizing communication, medicine, and technology. Its transparency, strength, and versatility have made it an indispensable component of our daily lives, from the windows that let in natural light to the medical equipment that saves lives. Moreover, glass's ability to be molded and shaped has given rise to a wide range of artistic expressions, from intricate sculptures to beautiful stained glass windows. As we continue to push the boundaries of innovation, it's clear that glass will remain an essential thread in the fabric of our modern world, shaping not only our physical environments but also our relationships, culture, and very way of life. This Silica sand washing plant, located in Vietnam, is a cutting-edge facility that converts low-value material into high-grade glass sand suitable for various industrial applications. The plant operates as a comprehensive beneficiation facility, utilizing advanced mineral processing systems to optimize sand specifications while minimizing environmental impact. The process begins with the efficient transfer of material from the feed hopper, facilitated by an integrated belt feeder and belt conveyor, ensuring precise material handling. The plant then utilizes atropia attrition cells, which play a crucial role in the process by efficiently removing contaminants and maximizing product yield. The attrition cells operate at 80% solids concentration, ensuring thorough scrubbing while minimizing power consumption, contributing to cost efficiency. Following the initial scrubbing stage, the sand undergoes further refinement through the max precision fine rinsing screen, which is crucial for superior screening classification and dewatering performance. The subsequent stage involves the utilization of SpiroPure spiral gravity concentrators, which provide accurate density separation to remove any remaining impurities from the final sand product. This step is essential for achieving the desired level of purity and quality required for industrial applications. Further refinement occurs with the Vertax upward flow classifier, which classifies particles based on size and specific gravity, thereby upgrading the feed material to meet optimal quality standards. The plant also features a Hydromax water recycling system, which plays a significant role in enhancing sustainability by delivering high water recycling rates, minimizing environmental impact, and reducing the space required for settling ponds. Additionally, the superior sand dewatering system, including the ScentScreen dewatering and sizing system, ensures that the washed sand is market-ready, maximizing revenue generation. Furthermore, innovative sludge management technology accelerates tailings drying, reducing the tailings footprint and allowing for quicker water recycling, further contributing to environmental sustainability. You might never know how glass bottles are made. In this video, you will learn how Rotel produces bulk glass bottles. Step 1. Raw material preparation. Raw materials of glass bottles include sand, soda ash, limestone, and cullet recycled glass. All of these raw materials are sourced from certified and trusted suppliers, then go through incoming quality checks before being used in the next step. Step 2. Batching and mixing. To bring a glass bottle design to life, the mixing portion matters. To make sure consistent quality of all batches of the glass bottle, the mixture portions have to be accurate. Step 3. Melting. The mixed raw materials are now being melted in the heating furnace under 1600 degrees Celsius. In this step, we get melted glass called gob, the original condition of a glass bottle. In a glass bottle factory, the glass furnace always works 24/7 to hold a stable temperature and reduce energy waste. Step 4. Blow glass forming. The molten glass are then molded into the desired bottle shapes in the blow-forming process. There are two types of forming process. For narrow glass bottles, such as beer glass bottles, wine glass bottles, or soda glass bottles, the blow-and-blow process is used. For wide-mouth glass containers, glass vases, glass candle jars, or milk bottles, the press and blow method is widely used. Step 5. Annealing. The glass bottles are moved into an annealing layer, which is a long kiln. In it, the glass bottles are slowly reheated and then gradually cooled again to a temperature below the strain point of glass. Step 6. Quality check. Any bottle with flaws will be automatically removed from the line. Experienced quality control can detect any flaws at the first sight of the final products. Flaws can be split finish, crumbles, deformation, molded seam, out of vertical finish, hammered appearance, thin walls, blisters, or cord. Step 7. Surface treatment. Surface treatments are performed on the exterior of glass bottles when they are complete. Step 8. Packaging and delivery. Glass bottles are vulnerable during transport. The warehouse department makes sure that the products are stocked properly before being delivered. Rotel utilizes several different shipping methods that ensures high standards of care and punctuality. In the heart of Mexico, a group of skilled artisans gather in a vibrant workshop where they come together to demonstrate their remarkable artistry in the ancient craft of glassblowing. With deft hands and years of experience, they fashion a stunning multicolored glass pitcher that is a true masterpiece of their craft. As the fiery furnace dances with molten glass, the artisans carefully manipulate the material, skillfully avoiding even the slightest misstep that could lead to starting over. The result is truly breathtaking, a hand-blown glass pitcher that showcases the brilliance of confetti-like patterns within its crystalline curves. In a celebration of sustainability, the artisans utilize recycled glass to fashion this vibrant fiesta of colors, destined for the prestigious Novica Handblown collection. Every step of the creation process is a testament to their dedication and mastery of glassblowing techniques honed over countless years. From the initial gathering of molten glass to the final shaping and cooling of the piece, each step requires precision, patience, and a deep understanding of the craft. The finished pitcher is a true work of art, with subtle variations in shape and size adding to its allure. Tiny bubbles nestled within the glass create a sense of depth and dimensionality, making each piece unique and extraordinary. No two pitchers are exactly alike, due to their handcrafted nature, making every one a true masterpiece of art and craftsmanship. The artisan's passion for their craft is evident in every detail, from the intricate patterns and colors to the delicate shaping and finishing of the piece. The result is a truly stunning work of art that is not only a beautiful addition to any home or collection, but also a testament to the skill and dedication of the artisans who created it. The process of converting raw materials into pristine, clear, flat glass is a complex and intricate one. At the Cardinal FG plant, hundreds of tons of raw materials arrive daily and enter the batch house. Here, the materials are precisely tested, measured, and mixed into a batch of dry ingredients that will eventually become glass. In addition to mixing batch, Cardinal employs a process called collet recycling. Collet is broken glass that is returned by customers and is mixed back into the batch. This environmentally friendly program reduces the need for raw batch ingredients by at least 15%. The full batch is then conveyed to an enormous 36-foot wide furnace that reaches temperatures of up to 3,000 degrees Fahrenheit. A charger pushes the batch materials into the furnace. The heat transforms these raw materials into a 4-foot deep pool of liquid glass. The liquefied glass then glides across a molten bath of tin. In the tin bath, the glass spreads into a wide sheet, or ribbon, where it is pulled and shaped into a precisely controlled thickness. It is here where skilled technicians can make adjustments to the glass configuration. The process is monitored continuously from the control room to ensure quality. The control room is the nerve center of the plant. Here, a manager overhears when the glass exits the tin bath and enters the annealing layer. The ribbon lifts right out of the tin. As it passes through the layer, it is cooled slowly to control the stress on the glass and ensure uniformity of thickness. The mass air section is the final phase of the annealing layer. This is where the glass is bombarded with air, driving the temperature of the glass down to where it can be cut. 20 miles of glass ribbon pass through the plant's cold end, producing more than 600 tons of glass each day. Defects in Cardinal's raw glass are almost unheard of due to an advanced system which includes cameras for defect detection, lasers for edge detection, and special lighting for manual spot checks. If defects exist, they are automatically marked and the cutting system cuts around the portion that is out of spec. The XY cutters score the glass with an amazingly accurate precision. After scoring, the glass is snapped with a bump roll which causes it to break along the score lines. All of the glass gets edge trimmed. The unused trimmings are captured below and are reused later as collet. Each glass pane then travels in real time through a computerized routing system. Arriving at the packing station, the airside orientation of the light is carefully managed. This becomes important at low-E coating operations where perfect untouched surfaces are critical. Thus, great care is taken to package, wrap, and label the orders before they are transported to customers in record time. With their tracking and stock locator system, Cardinal FG easily claims a turnaround time of 24 hours or less, benefiting their customers by offering them ultra-fast order fulfillment. Cardinal's expertise in laminating has enabled the company to provide exceptional service and quality to its customers. Each day, raw float glass from their FG plants arrives at the facility, where it is fed to the cutting table by a gantry system. A computerized scoring system then precision cuts the large sheets into smaller pieces, maximizing the utilization of every portion of the glass to achieve the highest possible yields. After being cut, the glass sheets proceed to the breakout area, where they are carefully bumped and separated into individual pieces. Any remaining glass is collected and recycled back to the float plants, ensuring minimal waste. Next, SEMA operators expertly grind the edge of each glass piece to enhance safety and durability. Finally, the glass is carefully placed on a rack, ready for further processing or packaging. To ensure the integrity of the laminated panes, a rigorous washing and drying cycle is performed to remove any particles that could compromise glass adhesion. Next, a laser logo is applied to the glass for safety glazing certification. The glass panes then enter a specially designed clean room, where technicians precisely place the interlayer onto one of the glass panes. A second glass pane is carefully positioned on top, and any excess material is trimmed away. The resulting glass sandwich is now ready for the two-step adhesion process. The glass undergoes an initial process in a high-temperature infrared oven, where the interlayer material is softened. Next, nip rollers compress the glass, removing air and creating the initial bond. The opaque glass is then loaded onto a rack. The second step involves the autoclave process, where the laminated glass is subjected to intense heat and pressure in a chamber. The temperature reaches 280 degrees Fahrenheit, and the pressure exceeds 12 times atmospheric pressure for a period of 2 hours. This process removes residual moisture and ensures the interlayer adhesively bonds to the glass, resulting in a clear product. Finally, technicians perform a precision trim of any remaining interlayer and move the panes to the online glass inspection conveyor for quality verification. With advanced technology, every pane of laminated glass is meticulously inspected by specialized cameras to detect any imperfections. Once cleared, the glass is carefully packaged and prepared for delivery. Cardinal LG stands out as a trusted supplier for laminated glass due to its commitment to quality and flexibility. The Taroma's 12-meter storage, loading, and glass cutting line is a comprehensive production system designed for efficient processing and manufacturing of glass products. It consists of a 12-meter long storage system, a loading mechanism, and a cutting machine, all integrated into a single production line. This system is ideal for large-scale glass manufacturers, allowing for high-volume production and reduced processing time. The storage system can hold a significant quantity of glass sheets, while the loading mechanism ensures accurate and efficient placement of the sheets into the cutting machine. The loader features an array of vacuum cups that handles the glass sheets. Each vacuum cup on the grid is fitted with a pneumatic cylinder to absorb pressure, adapt to possible irregularities, and avoid overstraining the glass. It also equips a series of sensors that detect vacuum level, pressure on the glass presence, and the exact position of the glass. In addition, each vacuum cup is assembled on a guide with a skid perfectly parallel to the movement of the grid towards the glass to assure that the approach of the vacuum cups is optimal. It's not a game, it's a rich thing. Once the approach to the glass is done, the loader vacuums the corresponding cups depending on the size of the glass. When the optimum vacuum level is detected, only the cylinders of the cups located at the upper ends of the glass are retracted to facilitate a correct separation of the sheet. The loader then checks and ensures the correct separation of the sheet from the pack by a series of horizontal and vertical movements of the grid, and then moves the sheet to the transfer table. The process prevents any glass breakage, ensuring effective separation and high performance. The glass sheet is carefully loaded onto the machine's table, which is designed to ensure precise alignment and movement of the glass. The 12-meter long cutting head is aligned with the glass sheet using a sophisticated system that ensures precise positioning and tracking. The cutting head moves along the glass sheet, following the programmed cutting path. The cutting head is equipped with advanced sensors that monitor the cutting process and make adjustments as needed to ensure optimal cutting results. During the cutting process, the machine automatically adjusts the cutting pressure to ensure optimal results. This ensures that the glass is cut precisely and without any excessive pressure or stress. The final cut glass product is then removed from the machine and prepared for further processing or packaging. And that's a wrap on our glass cutting journey. Glass is an incredible material that has been a part of human history for thousands of years. From its transparency and strength to its beauty and functionality, glass is a medium that has the power to transform our lives. Thanks for watching, and we'll see you in the next video.